All right, number 7 and 9 are both properties of exponent problems. And if you have two radicals being multiplied together, you can make one giant radical with everybody under here in one big party getting multiplied. Okay, so it's like 63 times x to the third times y to the seventh times et cetera, et cetera. So I'm going to group things together based on what type of factor they are. So 63 and 14 would be grouped together. X to the third and x would be grouped together. And y to the seventh and y to the sixth would be grouped together. Okay? So now we're going to go, let's attack the variable parts first. That's going to be x to the fourth because you add exponents. X to the third times x is x to the fourth. It's like there's a little 1 there. Y to the seventh times y to the sixth is y to the 13th. Again, we add exponents. Now, 63 times 14 is a big number, and I'm actually not going to multiply them just yet. Good, do 63 times 14. Somebody help me. 63 times 14. 882. Okay. Now keep in mind that all of this is still under the square root, and they want us to simplify. All right? Simplify means try to get as much as you can out from under the root. Okay? Try to get as much as you can out from under the root while keeping anything that isn't a perfect square stuck. Okay? So again, we may have some things come out here. Anything that can be square rooted will come out front. Anything that can't be square rooted will be stuck inside. All right? The first thing that I know can be square rooted is x to the fourth because it's an even exponent. So you have to imagine it as being x to the 4 over 2 using that fractional exponent rule. So it's x to the 4 divided by 2. What's 4 divided by 2? So x squared comes out completely. The square root of x to the fourth is x squared. It has been released from the square root. Y to the 13th is not even, it's odd. But if you break it up into y squared, y to the 12th times y, the blue part can be square rooted, but the red part will get stuck. So the blue part will come out front as y to the 6th, because again, it's like y to the 12 over 2. 12 over 2 is 6. The red y gets stuck. As I look up at my answers, I'm down to B and D as the two possibilities. Okay? D would be correct if the square root of 882 is 42. Is it? No, you could try it on your calculator. The square root of 882 is not 42. So I think this is a case where let's cut this in half and see what it breaks up into. 441. Cut 882 into 441 times 2. Does this have a square root? What is the square root of 441? 21. So that's the blue part that comes out front, but the red 2 gets stuck underneath. So it's looking like 21x to the second, y to the sixth, times the square root of 2y. B is the right answer. I'll do 9 as a separate video.